I'm going to subtract 6 to move it over to the right side. I left a space there on purpose. So I have x squared minus 12x equals negative 6. All of the x's on the right, or all of the x's on the left and the constant on the right. So that is the first thing you need to be concerned with. Moving the x's to the left, constant to the right. The second thing you need to make sure of is that your coefficient on x squared is 1. So now we are going to divide everything by 3. To get x squared minus 4x equals negative 2. Now we're going to do the process of completing the square. Ignore the constant for right now. That negative 2, it doesn't have anything to do with completing the square. For right now, all we're looking at is x squared minus 4x. The process of completing the square. Take the b term, negative 4, divide it by 2, and then square it. Negative 4 divided by 2 is negative 2. Negative 2 squared is 4. So we complete the square by adding 4, which is why I left that open space. I have just completed the square. By adding 4, that is the process of completing the square. Now, I also have to add 4 onto the other side of the equation to maintain the equality of the equation. If I'm adding 4 to one side, I need to add 4 to the other. Nope, not yet, because we're solving. So we need x values if that's our answer. So right now, I have x squared minus 4x plus 4 equals 2. Remember, we completed the square, so we had a perfect square trinomial, and we can easily factor that perfect square trinomial by saying x minus 2 quantity squared equals 2. Now this should take you back to, I believe it was example problem number 3 from this section, where you have your perfect square trinomial and you're solving. You take the square root of both sides. Taking a square root gives you a positive and negative answer. Keep solving for x. X equals 2 plus or minus the square root of 2. So you have two answers there. You have 2 plus root 2 and 2 minus root 2. If it makes more sense to you to write them separately, you certainly can, but just using the plus and minus sign is sufficient. So this problem just puts together all of the different steps we've done so far in this lesson. The completing the square process and then the solving process. Let's try the next one. First, we want to reorder the quadratic, so we have ax squared plus bx equal to c. So move all of your x's to the left side and the constant to the right side. What else do I need to do before I can even complete the square? There's another step that I need to do. Cody?
Divide each side by 2.
Very good. Because you always want your coefficient on x squared to be 1. So we have x squared minus x equals 3.
Divide everything by 2.
My blank space there is there because I need to complete the square. What's your b value?
1.
Not just 1. Take the sign.
Negative.
-1, right. So we have -1 divided by 2 and then square it. Now, if you need to, you can default to a calculator, or we could just do this in our heads. This is the same as saying -1/2 times -1/2, which would give us 1/4. Whatever you complete the square with, that value also has to be added onto the other side of the equation. So far I have x squared minus x plus 1/4 equals 3 1/4. Now you can write that as 3 1/4. I'm going to make it 13/4 because I would rather deal with the improper fraction. You could make it 3.25. It's all the same value. So now we need to finish our solving process. So we need to take our perfect square trinomial and we need to factor it. So we have x minus what? Jess? Very good. How'd you get 1/2, Jess? Right. It's just like taking the square root of 1/4. The square root of 1/4 is 1/2. And that equals 13/4. Now we need to take the square root of both sides. Just a little side note, remember your rules of radicals. If I have the square root of 13/4, that could also be the square root of 13 over the square root of 4. So what could that simplify to? Ashley?
Square root of 13/2.
Very good. You should. I wouldn't mark it wrong if you didn't, but just for future problems, it's going to be more helpful if you do. So I have x equals 1/2 plus or minus, we just found the simplified form, square root of 13/2. So this is all of section 4-6 in one problem. Completing the square, factoring the perfect square trinomial, and then solving. So you can use this process to solve. You can also use this process to get our equations into vertex form. If you remember back in the first sections 4.1, 4.2 of chapter 4, we used vertex and standard form. So if you look at problem number 6, it's going to ask you to write these in vertex form. Remember, standard's what we've been using. Y equals ax squared plus bx plus c. Vertex form, does anybody remember it? Christy? Awesome. And both of those had some special properties. In standard form, your C value was your y-intercept. And what do H and K stand for in vertex form? Cameron?
H is X and K is Y.
The X and the Y of what point? You're right, they're the X and the Y of what point? You're thinking too hard. What form is this? H and K are the vertex. That's why we call it vertex form. H and K are the vertex. Okay, you're not completely wrong because you're thinking two symmetric points and then the middle point is the vertex. I understand. Okay, so we've got our two forms. C is the y-intercept. H and K are the vertex. So what is y equals x squared plus 4x minus 6 in vertex form? What we're going to do is we're going to take this and we're going to complete the square. So I'm going to take x squared plus 4x, and then I'm going to move the 6 onto the right side. Because remember, when we're doing completing the square, we need ax squared plus bx equals c, equals the constant. Now I need to complete the square. B divided by 2 squared. 4 divided by 2 is 2. 2 squared is 4. So I'm going to add 4. So now I have x plus 2 quantity squared equals 10. Now I'm not solving. Remember, this isn't asking for a solution, it's asking for vertex form. So this kind of looks like vertex form, doesn't it? Except for what? What should I move here to get it into my vertex form? Move the 10. So now I have x plus 2 quantity squared minus 10, and that is my vertex form. So y equals x plus 2 quantity squared minus 10. That's part of the answer. That's vertex form, and now it wants the vertex and the y-intercept. Any volunteers to give those to me? Be careful of the sign in your vertex. Jordan? -2. Did you say -10? Yeah. Okay, good. I just didn't hear you. And what about the y-intercept? You have to go back up to standard form for that one. And just look at your C value from standard form. -6. -6. Okay, let's try got it number 6. We're going to start with x squared plus 3x. Now I'm going to move this 6 onto the other side of my expression because I want to complete the square. To complete the square, b divided by 2, quantity squared. Think about this. 3 divided by 2, quantity squared. b over 2 squared. So that just means 3 over 2 times 3 over 2. What value completes this square? What is 3 over 2 squared? Sid?
9 over 4.
Right. So I'm going to add 9 over 4 to both sides. Now you need to factor your perfect square trinomial. So that's going to be x plus what? Sid? Jess?
3 over 2.
Right. Now, 6 plus 9 over 4, common denominators, that's 24 over 4 equals 33 over 4. Or 8 1/4, 8.25, however you want to write it. I want this to be in vertex form, so I'm going to move that 33 over 4 back over to get y equals x plus 3 over 2, quantity squared, minus 33 over 4. And then the last part is to name the vertex and the y-intercept. Who can give me the vertex? Christy. And negative. Did you say 8.25? Okay, I just didn't hear you. And then go back to your standard form to get your y-intercept. Gabby?
-6.
Very good.